So what we do is we introduce a dummy type, which becomes part of the function signature. And this type sort of represents, in some sense, the type of vector, sort of. But we're just kind of abstracting over it by making it a function parameter. And then what we're going to accept is we're going to accept the constructors for vector. So the first constructor is just a vect of a0. But the second constructor, which is not going to fit on this line, so I'll do it down here. The second constructor is of type a2 vect an2 vect a successor of n. And then if you can give us this type and two constructors, shit, this type is wrong. This type should be u0 and u0. If you give us a type and two constructors, then you can have back the type, like that. And so then the constructors, and this is a closed form. This is not the kind of open form from before whereby you just declare everything that is of your type and it just sort of adds it to the definition of the type or to the objects of that type. This is a kind of closed form of sorts because you have to supply the two constructors, the nil constructor and the const constructor. And so the function nil, or the value, I guess, the value nil, its definition becomes u0 and u0. And then, so we get the type, we want the what else do we need here? We need the nil constructor, which is vect a0. Then we need the const constructor, which is that madness. And then what we return is nil. All right, we just return the nil constructor. We may be able to get away with not having that. And so then nil is of type, well, we take in this. And what do we return? Well, okay, so what do we have here? What we have is a function. We have a function which takes an x, which takes the nil constructor, which takes this constructor, and returns the nil constructor. There we go. And returns the nil constructor. Well, that's exactly what the type of vector is. So this is actually just a vector a0. And then similarly for cons, we do the same thing. We have u0, we have n, which is type n. Then we're going to take in what's the best way of doing this? We'll take in an a of type a. We'll take in a vs of type vect an. And then we'll take in our x of u to n to u, and our what else do we need here? xa0, nil constructor of xa0, and we'll also take in our cons constructor of that garbage, and then what we're going to return is we'll call our cons constructor with a and vs. And so the type of this, we take in a, we take in n, we take an a, we take a vect an. And if we cut off our parameters here, what's left? We take in an x, we take in the nil constructor, we take in the cons constructor. So we take in an x, we take in the nil constructor, we take in the cons constructor. And then what do we return? Well, we return those two things, the cons applied to a and vs, which is exactly this type here, vect asn. So yeah. I don't know. I maybe need to think over it. I was going to say something that I maybe need to think over, so I maybe won't say that because it could be wrong. So I'm not going to say the thing I was going to say. But the point is that here, this is a closed form. We define vect in terms of its two constructors. We can't add any more constructors to this vect type. They're fully enumerated in this type definition. So, okay, what's the problem with this? The problem with this is that it's all functions. Let's try to do the same thing we did before. Let's try to write our map. All right. We'll try to write the map function for before. Jeez, my tablet hand's getting sweaty. It's temperature here. 23 degrees? Yeah, it's not too warm. Okay, so let's try to map the map function from before. Okay, so we need to take an A of type U0. I guess we'll do it this way, an N of type N, a B of type, oh, these should be an N of type N, a B of type U0, and then a function of type A to B, and then a vect an, and we get back a vect bn. Okay, let's try to write this. Okay, so firstly we'll do all our lambda parameters. I should really drop the type signatures. I already have them up here, but whatever. All right. How are we going to do this? Well, we want to match on VS somehow. But how? How do we do that? Now one of the ways, so, okay. So VS is, a composition of these cons and well, let's move this down. We'll move this down. We'll write out a vector manually first. Go down there. We'll come back to you. We'll write out a vector manually. So if we want vs to be of type vect natural number 2, then what are we going to do? Okay, so we want it to be a cons, which is what? It's a function which takes a bunch of shit. So natural number 1, 7, and then we want a nil, which just takes an n. And then what it returns is all this shit here. So the type of this vect n2 is a function type, right? It's x, u, 0, n, u, 0. N, x, well, in this case, the a is already set, so it's x, n, 0, 2, and then all that garbage for the cons constructor. And returning an x and 2. So what we could try to do is we could try to, well, I mean, if vs is this function type, we could try to give it some functions in here to extract, kind of match on it that way. So, all right, what do we want to do? So what we want to do is we want to make the nil cell in this map function. We want nil a to essentially go to just nil b, basically. And we want cons to go to f, well, cons fa and everything else. So let's try to apply that function to vs. So if we go vs, and then we try to give it a function like this. And we'll see if we can expand it out. There's a lot going on here, so we might not be able to, but we'll see if we can. So we're going to give vs its first argument will that work? I think this should work. But how do we supply that? So if we want to return a vect, oh, right, okay. Okay, so we want to return a vect, and what is a vect? It's this garbage type, so we're going to try to return a vect. So we'll take in our x of u0 to n to u0. And what else do we need to take in? We need to take in our nil constructor of type vect